Hello everyone, today I am going to present an innovation system called agent sensor-based Gait analysis system for stroke risk identification in old adults. This system uses wearable sensors and machine learning to analyze walking patterns and detect early signs of stroke. This work has developed as my final year project. Stroke is a major global health issue and leading cause of disability. Early detection is very important to reduce severe complications. One of the early indicators of stroke risk is changes in walking pattern, also known as gait. So in this picture, you can see the gait cycles. So how we start the gait cycle and how it is end. As shown here, the gait cycle include different phases such as stance and swing. As shown here, the gait cycle include different phases such as stance and swing. By analyzing these patterns, we can identify abnormalities. In this project, we use wearable IMU sensors, capture walking data and analyze it to detect stroke in early stage. Now I will explain the main equipment used in this project. First we use the DNO055 IMU sensor. This sensor combines an accelerometer, gyroscope and magnetometer to measure motion and orientation. It helps us capture accurate movement data during walking. Next we use ESP32 microcontroller. It is responsible for collecting sensor data, processing it and transmitting it wirelessly. It is compact, low cost and suitable for real-time application. While we use machine learning algorithm, basically we use linear regression model. Basic algorithms analyze the extracted gait parameters. When it comes to the gait parameters, that mean walking speed, distance between the two legs and a number of steps per minute, like those parameters. This helps in identifying whether the gait is normal or showing signs of stroke risk. So these three components work together to collect, process and analyze gait data effectively. So in here I'm going to explain how the system design. First the process starts with human walking. We capture the walking motion using the DNO055 IMU sensor which is attached to the legs. The sensor collects motion data such as acceleration, angular velocity. This data is then sent to the ESP32 for data acquisition, like this. So walking data collected by IMU sensor, then IMU sensor send those data to ESP32. After the ESP32, the collected data goes through gait analysis. The important walking events like heel strike, toe off are identified. Simply in here we do the gait analysis to get the gait parameters like walking speed and number of steps per minute, distance between the two legs. So after that data pre-processing stage. After that data is passed to the data pre-processing stage where filtering techniques are applied to remove the noises and improve accuracy. Then finally model development. Where machine learning algorithm like linear regression model we used to classify the gait pattern as healthy or stroke affected. So overall the system convert raw motion data into meaningful insight for early stroke detection. So when it comes to the hardware development process, first we design PCB using easy IDE software, so which includes the ESP32 microcontroller and all required components. This is define the circuit connection and layout. Next, design PCB layout is printed onto the photo paper. This printed layout will be used for transferring the circuit pattern Finally, prepares are from copper bond, which is base material used to fabricate the PCB. So these steps are involved in designing the printer, then preparing the board for PCB fabrication. So this is just normal how to design the system. First we design PCB using easy ID software, so which includes the ESP32 microcontroller and all required components. This is step one, define the circuit connection and layout. Next, design PCB layout is printed onto the photo paper. This printed layout will be used for transferring the circuit pattern. Finally, prepare R for copper board, which is base material used to fabricate the PCB. So these steps are involved in designing the printer, then preparing the board for PCB fabrication. So this is just normal how to design the system. In these 4 and 5 steps are also regard to the how the system, how the this PCB developed. Finally, we attach this IMU sensor. The green color is guys the IMU sensor. Then this is the USB board. Yeah, the figure 6 shows the final component. So we need two PCBs because we have 2 legs. Then the figure 7 shows these 2 PCBs, and figure 8 shows this shocks band because we should have to be height into our legs, so we need to create this kind of socks. In this PCB was attached to this socks. So figure 8 it shows the outer appearance, and figure 9 shows it inner appearance. So in this video it shows how this system works. So this slide shows the demonstration of how entire system works in real life. As you can see, the IMU sensor are attached to both legs using the wearable bands. When the person starts walking, the sensor continuously captures the motion data. So this slide shows the demonstration of how entire system works in real life. As you can see, the IMU sensor are attached to both legs using the wearable bands. When the person starts walking, the sensor continuously captures the motion data such as acceleration and angular movement. This data is they transmit to the ESP32 where it is collected and processed. So I will play the video. Then you can see. Basically, we need the weight because people walking pattern different from the how their weight and their height also. Those are affect to the walking characteristics. This is the website we developed. When we start in walking, we should have on this on the. Also, this is the website that ESP32 connected this website. So when you start the walking, you should have to press this start button. Then the end of the walking, you should have to press the stop button. Then you need to go to this raw data upload tab. Then you can browse the file which is related to the raw data. Then I have collected raw data of the patient. So example as one page we can get from the one patient. So yeah, then we can put into the here. Yes, he is a stroke affected one, and it gives the comprehensive data set like this. I mean, comprehensive gait report. Cadence means a number of steps per minute. Stride means distance between the legs when the person walking, and the walking velocity. Stance mean how much the time for the step. In swing time, double support time mean what is the time should both leg